Question 23. Evaluate sine raised to power 3s ds. Solution. The integral of sine cube or sine raised to power 3x ds is the same thing as sine squared integral of sine squared s times sine s ds, which will now give us, since we know that we have from trigonometry, one of the rules in trigonometry is that sine squared s is equals to 1 minus cos squared s. So we substitute 1 minus cos squared s, and we have 1 minus cos squared s sine s ds. Then if you open the bracket, we now have integral of sine s minus cos squared s sine s ds, which we now have as minus cos s plus cos raised to power 3s over 3 plus c. Cos raised to power 3s is because we have gotten our cos squared s sine s previously, the integration of cos squared s sine s to be equals to cos raised to power 3s. That is why we now have to replace it. They are the same thing. Cos squared, the integration of cos squared s sine s is equal to cos 3s. Question 24. Evaluate the integral cos raised to power 3x ds. Solution. The integral of cos raised to power 3x ds is equals to integral of cos squared s times cos s ds, which is equals to the integral of, in bracket, 1 minus sine squared s, because cos squared s is the same thing as 1 minus sine squared s according to the laws of trigonometry, times cos s ds, which is equals to integral of cos s minus sine squared s cos s ds, which is equals to sine s minus sine raised to power 3s over 3 plus c. Since we have gotten the integration of sine squared s cos s previously to be equals to sine raised to power 3s, then we simply replace sine squared s cos s with sine raised to power 3s. Integration by parts. Let u and v be the function of x. Recall from the product rule that the differentiation, that is the uv over the s, is equals to u the v over the s plus v the u over the s. Therefore, the integration of the uv over the s is equals to the integration of u the v over the s times the s plus integration of v the u over the s times the s. If they cancel out, we'll be now left with vu is equals to integral of u dv plus integral of v du. Therefore, if we make the integral of v du the subject of the formula, we have equals to uv minus integral of u dv. Solution. Evaluate the integration of s sine s ds. Solution. Put v equals to s and u equals to sine s ds. The v is equals to the s. U is equals to minus cos s. Therefore, integral of x sine s ds is equals to minus s cos s plus the integral of cos s ds, which is equals to minus s cos s plus sine s plus c. Example 26. Evaluate the integral of x exponential s ds. Solution. Put v equals to s and let our du be equals to exponential s ds. Then the v is equals to dx, while u, if we integrate u, we now have exponential s. If you now substitute the values into the formula, integral of v du equals to u times v minus integral of u dv. Therefore, which is equals to the integral of x exponential s ds is equals to s times exponential s minus integral of exponential s ds, which is equals to, if you now integrate exponential s ds, we will now be left with exponential s, which will now have s exponential s minus exponential s plus c. Therefore, if you bring the like term out of the bracket, we now have in bracket s minus 1 exponential s plus c. Question 27. Evaluate the integral of s log to base e exponential s ds. Solution. Put v equals to log base s, while the u equals to s ds. The v is equals to the s over s, while u is equals to s squared over 2. Now from the formula, the integral of v du is equals to uv minus the integral of u dv. Therefore, substituting the values in the formula, we now have the integral of s log to the base e s ds is equals to s squared over 2, that is u times v, which is log base e s minus the integral of s squared over 2, that is u times the v, which is the s over s. Therefore, all they now have is equals to s squared over 2 plus log base e exponential s minus the integral of s squared over 2 ds. Then what we now have is s squared over 2 log base exponential s minus s squared over 2 plus c. Then we now have s squared over 2 log to the base e minus s squared over 2 plus c. The answer will now become s squared of, if we take out the like terms together, since s squared is the like terms, we now have s squared over 2 in bracket log to the base exponential s minus half plus c.